What up? Let's learn about the Pythagorean Theorem. Essential question: how can I use or apply the Pythagorean Theorem in order to solve for unknown sides of right triangles? So this is a theorem that you have definitely learned before. Here's your essential meme of the day. It's a really, really bad joke. If you don't get it, you will soon. Okay, definition: Pythagorean Theorem. This is the most famous theorem in all of math. It's a squared plus b squared equals c squared. It has extremely many uses, comes up all the time in the real world. Big deal for engineering because it applies to right triangles. And look around your room. Right now, look around. See those walls, how they connect with the ceiling? There's a right angle in there. See how the walls connect with the floor as well? There's a right angle in there. And every time we have right angles, there's the possibility to have right triangles. So the Pythagorean theorem has to do with right triangles, meaning one of their angles is a right angle. And what the Pythagorean theorem says is, if I take this side and square it, and then add it to this side and square it, I'm going to get this side and square it. And it seems simple, but it's actually kind of really amazing. Like literally every single right triangle, no matter how big or small or what its shape, as long as it has a right angle, its sides are going to do this. Now there's a couple things we have to note. First of all, C, this is the side across from the right angle. This is called the hypotenuse. And I'll just write it's across from the right angle. Across from the right angle. That L means right angle. Across from the right angle. Okay, these two guys, the A and the B, we call these the legs. They are touching the right angle. Touching the right angle. Notice how in the formula, C is the guy on the opposite side of the equal sign. So that's important to remember. Oh, I misspelled hypotenuse. The hypotenuse is always C. Also, it's interesting to note, and it will help us to do the problem, that the hypotenuse is always the longest side. And we'll talk about how to kind of use these facts as we're problem solving through the problems, okay? But here we go. C is always on the opposite side. A and B are the legs. They're shorter than the hypotenuse. Okay, let's just do some examples. They're actually really easy. Example 1. A fireman must save a girl from the second story of a burning building. Okay, so let's start drawing this picture. I have a burning building. The whole reason I picked red for today is to represent fire. And just in case this doesn't look enough like fire, it is, I promise. And here's a small little child, and she's screaming for help. The fireman must come and rescue her. She's 10 feet up in the building, okay? So what the fireman's going to do is he's putting his ladder 12 feet. He's putting his ladder 9 feet away, and he's going to lean his ladder there, and he's going to rescue the girl. And we know that the ladder is 9 feet away from the building. So here's the building, there's the ground, here's the ladder, and our goal is to see how long must his ladder be. So basically I'm solving here for x. Now, what do I notice about this problem? It's a building contacting the ground. Do we think there's a right angle in there? Definitely. Almost all buildings have right angles to the ground unless they're crazy, weird shaped building. Like there's that one in England that's like an egg, something like that. That one doesn't have right angles. Basically all the rest of them do. So we have a right triangle. So I should be able to use a squared plus b squared equals c squared in order to figure out this problem. I just need to make the decision, what is a, what is b, and what is c? Well, remember, c is the hypotenuse. It's the side across from the right angle. In other words, in this problem, c is x. That's the thing I'm solving for, because this is the side across from the right angle. So let's put x in for c, or you can totally just leave it as c. Let's actually do that. It's kind of stupid that I decided on a different variable to use. Let's just use c here. Like, why not? Okay, a and b are the legs. Notice that both of these sides touch the right angle. They are the legs. Does it matter which one is a and which one is b? No, it doesn't. Let's just call this A and this B. But it really doesn't matter. If you called this B and this A, it would also be fine. Okay, so 12 squared plus 9 squared. And let's solve this problem. I'm trying to solve for c here, of course, but I'm going to need to take the square root to cancel the square eventually. But it would help if I just had a number on this side. So let's do a little simplification using order of operations. I know 12 squared is 144. I know 9 squared is 81. And then I can also just add these together. 144 plus 81 is going to be 225. And that's c squared. So now I have just a number on the left-hand side, and so it is a great time to square root. Remember, square and square root are opposites. So I'll be left with just c. What's the square root of 225? Well, it's 15. Now, I should use the plus or minus 15 technically, right? Because every time I take the square root in a problem, a plus or minus shows up. However, think about the problem. Does it make sense for the side of a triangle to be negative? No, definitely not. So we're just going to use positive 15 here. And let's just make sure to put in my units, feet. Now we can check our answer to see if it makes sense. We can check by plugging back into the formula. But also, remember, the hypotenuse should be the longest side. If my answer is 15, is that the longest side? Well, yeah, it's longer than 9 and 12. So this answer is sensical. Okay, next one. In a right triangle, one leg is 4, the hypotenuse is 7. What's the other leg? Okay, so let's just draw this right triangle real quick. We can draw any right triangle we want. We're saying one leg is 4, we're saying the hypotenuse is 7, and I want to know what is this length. So remember, the legs are always A, B, or C. Let's call this A. I'm solving for B. And the hypotenuse is c. So when I'm plugging into my a squared plus b squared equals c squared, 4 would go in for a. I'm going to solve for b squared, and that's going to equal 7 squared. Now, I see this common mistake. People don't think about what are the legs and what are the hypotenuses, and so they just do this. 7 squared plus 4 squared equals c squared, la la la, solve. What's wrong about this? C, it's always the hypotenuse. That's 7 in this case. If you just randomly stick things into the formula, you might not get them in the right places. It's very, very important that 7 is on the opposite side of the equal sign because it is the hypotenuse. So don't make that mistake. Actually think about what goes where in the formula. Okay, so let's actually solve this one. 4 squared is 16. Let's just simplify some of these things. 7 squared is 49. Now, I'm trying to isolate b here, so before I take the square root, I really need to get rid of the 16. So let's subtract 16, b squared equals 33. And now I'm going to take the square root to cancel the square. Again, technically it should be plus or minus, but negative sides don't make sense. Now, I could put this into my calculator. It would be somewhere around 5.7. I don't know. You can actually put it in and see what it would be. But remember, in this chapter, I'm really more concerned about like simplifying the square roots and reducing them. So let's just make sure there's nothing I can like pull out here. 33 is 3 times 11, and that's it. Are there any perfect squares in there? No. So I'm just going to leave this as my answer, it is a fully simplified square root. Done. Okay, I have one more example. A triangle has side lengths 3, 7, 13. Is it a right triangle? And then I wrote a really bad joke that I'm not going to repeat because I actually hate bad jokes, but I thought of it and I wanted to draw attention to it. This is a bad joke. Boo. Okay, so basically here's what's going on. We have a triangle. We don't really know what the angles are, and the question is there a right angle in here or not? So think about how I can solve this. What do we know about right triangles? Well, in order to be a right triangle, you have to obey a squared plus b squared equals c squared. So what I can do here is I can see if these sides fit the formula. If they don't, it's not a right triangle. If they do, it is a right triangle. So let's see if I plug these sides into the formula, if it'll work. Now we need to make a decision about what goes in for C, because remember, C needs to be the hypotenuse. But since I don't actually know where the right angle is here, like it could be here, it could be here, how am I going to decide what the hypotenuse would be? Well, remember, the hypotenuse is always the longest side. So that 13, if this is a right triangle, if that is the hypotenuse, that 13 is going to be my C because it is the longest side. So let's put 13 in for C. We'll put 3 in for A, 7 in for B. Again, these don't matter. You could switch them. And let's just solve it and see if one side matches the other. 3 squared is 9. 7 squared is 49. 169 is 13 squared. This plus this is 58. Does 58 equal 169? No, not even close. So since these don't equal, we could say the Pythagorean theorem fails, it doesn't work for this triangle. Therefore, this isn't actually a right triangle. Therefore, not a right triangle. The reason I know is because if it was a right triangle, it would be matching the Pythagorean theorem. All right, so here's your summary. Pythagorean theorem, a squared plus b squared equals c squared, works for right triangles. Remember that C is always the hypotenuse, the side across from the right angle, the longest side. A and B are the legs, the sides touching the right triangle, or the right angle. Should be a pretty easy section. Easy formula to memorize, easy formula to apply. Thanks for watching.